Advanced Math Lesson 62, Abstract Coefficients and Linear Variation. Cool thing is we're not actually learning any new math, we're just applying it to some complex looking problems. Abstract coefficients, we'll go to my example, is this. We're going to use solving by elimination to solve for an x or a y, and the abstract coefficients are all these letters in blue. Normally we would have this with whole numbers, like 2x plus 3y equals 12. But in this case, all the coefficients are abstract numbers or variables like a, b, c, d, e, f. The best way to solve for these is to use elimination. You could use substitution, but then your answers get really convoluted, and then you usually end up with like adding abstract fractions, and it becomes a mess. So when you're faced with these types of equations, you definitely want to use elimination. It's the most direct method. Let's go ahead and we'll eliminate the, I forgot one thing. The book tells us to solve for y. So I was just about to solve for x. So we have to solve for y. So let me check here. Yep, it looks like the book is only going to tell you to solve for one of these unknowns. That'll make life a little bit easier. So in this equation, they want us to solve for y. So if I want to solve for y, then I need to eliminate the x value. So I look at what coefficient I could eliminate x. And so if you remember, if we're going to use the elimination method, we have to make sure that our coefficients of the unknown we want to eliminate are the same and then opposite signs. So to make this the same, I would have to multiply this bottom equation by negative a and the top equation by positive d. What that does is it rewrites everything to where this first term can be eliminated and there will be no more x. So when I multiply, the top equation is going to become a dx plus b dy equals c d. The bottom equation when I multiply is going to be negative a dx minus a ey. That's going to equal negative af. Here the elimination is pretty clear. We've got same term, opposite signs. So when I add, that eliminates. Here, these are unlike terms, so they can't add. So I'm just going to write them as b dy minus a ey. And then here, these are also unlike terms. They cannot be added, so that's going to equal cd minus af. From here, it just becomes solving an abstract equation. So if you remember from solving abstract equations, we're going to take the unknown we're looking for, which is y. We're going to factor it out like a greatest common factor. So I'm going to pull y out of the polynomial here, and that number will become bd minus ae. And that's going to equal cd minus af. From here, the last term to solve for y is going to be to divide both sides by the coefficient of y, bd minus ae. Those cancel, and y is equal to cd minus af over bd minus ae. That's your answer. Our abstract coefficients can look a little funny. No, the one in your lesson's a little traditional. Let me see if I can find a crazy looking one in a later lesson, because sometimes they'll throw subscripts in here just to see if it'll confuse you. If I can find one. Hold on. What? I don't see one. Okay, well, I guess those aren't coming for a while because I just peeked all the way forward to lesson 72. So just remember, use elimination. Don't forget your rules of abstract equations, and those are pretty simple. The next lesson, which is called linear variation, this linear variation is just essentially trying to find the equation of a line when you're given data. So this example that they use in the book is the total cost varied linearly with the number produced. When 100 were produced, the cost was 700. When 400 were produced, the cost was 2200, right? An equation that gives cost as a function of the number produced. The equation is going to be a line, and then these values of number produced and cost are going to be like x and y coordinates, right? So the first coordinate we're going to have is, if 100 were produced, the cost was 700. So 100 will be our x value, 700 will be our y. So we'll go ahead and we'll write that down as a coordinate point. So we've got 100 items at $700. The next one is 400 items at $2,200. And again, like I said, this is just finding the equation of line of a cost trend, and it's linear, so it's not going to have any curves or oscillations. It's just going to be a straight line. We have two coordinates of our straight line, and if you have two coordinates, you can find the equation of your line. So we'll start with our base equation of the line, which is y equals mx plus b, and we'll start filling in some blanks. First, we know we can solve for the slope of m if we use slope equation, which is y1 minus y2, so 700 minus 2200. Whoops, that's a 22. It just looks ugly. Whoop. What's going on with my camera? There we go. Stay in one spot, buddy. All right, and then so difference in y over difference in x, so 100 minus 400. Okay, so 700 minus 2200 is going to give me negative 1500. And then 100 minus 400 gives me negative 300. Negatives cancel, which is nice. Zeros, and 15 divided by 3 is 5. So m is equal to 5. So I've got one part of my equation solved. So I know my answer, y is going to equal 5 times x plus b. Now the last thing I need to do is solve for b. Lucky for me, I have two different coordinate points here I can plug into my equation. The first term being x, the second term being y. So I'll plug in this 100 and 700 because they seem like they'll be easier numbers than 4 and 22, but we'll see. So if y is 700 and x is 100, then I've got 5 times 100 plus b. So now I just got to solve for b. 500 plus b equals 700. If I subtract 500 from each side, then I get b is equal to 200. Excuse me. So I'll take this and plug it back up into the top equation, which gives me a final linear equation of y equals 5x plus 200. Now the last thing we're going to do, since this is an equation of data and there's a specific line we're thinking of, we're not going to use x and y. We're going to use the variables in the equation, which the variables are cost and number of items. So if we remember, the number of items was 100, the cost was 700, so x is going to be number, y is going to be the cost. So we'll write this as the cost equals 5 times n sub I, number of items, plus 200. That'll be my final answer. So the last thing, just make sure you don't put it in linear form, but put it in the data form. So make sure your unknowns are labeled, whatever they may be in the equation. That's it for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.